Chester, 0 Java 33M. Tell Java because it works on all platforms is like saying anal sex is good because it works on all genders. In Chester, 33M. C++ will do for C, but algol 68 did for algol. Managers. 36 in Chester, 0 C++ 33M. Why C++ programmers prefer dark mode? Because light attracts bugs, meganef USMA. 0M.
Oh, I'm streaming. Wait, I started the stream already? When? When? Oh. Wow. My bad, guys. I didn't realize. What did I even do in the past few minutes anyway? I just didn't do anything. Probably just sat there and did nothing for like, I don't know. Oh, did I look at FVWM3 themes? Maybe that's what I was doing. I have something for you all today. A C++ toolchain for your GPU. I want to learn about this today. Why do I want to learn about this? Because it's LLVM, and I'm an LLVM, a D1 LLVM enjoyer. I enjoy LLVM, by the way, guys. Look at that thing. What the fuck is that shit? Is that fucking NVIDIA's, fucking NVIDIA Pro Max? What is that block? And can I have it? Sudo, can I have this block, please? Alright, so they gave us this beautiful presentation, and I think it's open source, because I found it on the internet. It has AMD all over it, which I'm not a fan of big proprietary companies like AMD. I like small companies like Bolt, because they're cool, but also... Anyway, introduction to GPU. Modern GPUs have evolved into general purpose accelerators. Provides a C++ toolchain that runs on the GPU, trivially port applications to run on the GPU, run implementations of math/utility functions, run unit tests on the GPU. It's also fun, which they're not wrong. The little bit of AMD GPU joy I got was like with C#, and I hate .NET because it's slow as piss. That's frozen and full of rocks because of kidney stones. How to port the existing C/C++ libraries to the GPU? Lots of options. So you have targeting GPUs with CUDA/HIP on this one. Ubiquitous for targeting GPUs. GPU code is manually declared, global, and device. Global. And you just do C Clang HIP point C, and that's Clang, by the way. So Clang would be compiling C++ code. Difficult to integrate into, but the problem with this is it's difficult to integrate into existing build systems. One compiled job yields many files. Host device and compilations must both compile. Less portable. Compiled by the Clang front end, and I'm clanging it. Yeah. Finally arrived in time. Me? Yes. But also, I think today we're gonna have to plug in the other box, le big computer, the Grandmaster Arcane computer of all time. Okay, so here we have targeting GPUs, OpenCL. Oh, actually, we skipped OpenMP. We skipped the best one. OpenMP is what we need. by the way. OpenMP is amazing. So uses a C++ compiler with uses C++ compiler pragmas, more standard C++, same issues with build systems. Very portable, however, which is what I like. Compiled by Clang frontend, uses same built-ins, and I think that's C, but that's C++, and C++ mega scary. I wonder if there's a C wrapper for OpenMP. Another option is OpenCL. It uses a more conventional approach, easier to fit into existing builds, it's fundamentally limited. No function pointers, no recursion, conflicting definitions of the C functions. OpenCL C++ has templates at least. Also compiled through Clang frontend. The runtime uses the same built-in functions. You get the idea. Targeting GPUs, C/C++. Why bother porting anything in the first place? All these languages are just different versions of Clang. We can just target C/C++ directly without a GPU language. Use target AMD GCN-AMD HSA to invoke Clang target. Our linker is ld.lld, so we can use LTO and static libraries. Don't specify -mCPU and we can get a generic LLVM IR. So that's the intermediate representation. But let me go ahead and set up this fucking thing because I gotta plug it in and shit, and then we can start getting into the GPU server to do some GPU compute. You know what I mean? Let me see where's a good spot to plug this shit in. This will be awesome, by the way. You know what? I'll set up the camera too. Why not? But I'll do that last. Let me see. Oh, wow. Alrighty. This is great. Give you all an epic view of the server today. Once it's set up. That's awesome. Oh shit. Do 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 do. Oh. Put that shit under there. Plug her in. Plug it off. I haven't logged into it, so I'll need to update it. It's been a minute. Alright, there we go. Let's get this shit on the... Let's get this shit trolling. Not even rolling, trolling. Nope, not looking for that one. The camera mode. Oh wow. Field of view. The best view. Let's find the best view for the camera. Oh, I see the Archbox wants to make itself in the video. The end video. My huge data center right here. Damn, bro. Every computer all running. Well, not all running, but for the most part, everything's good. Wonder what that desktop is. This is the server. But here, I mean, you can't even really see it because it's backwards, but. The joy of rotating things mid-operation. Wowie. Let's change shit up and rotate it mid-operation. There we go. That is beautiful. GPU-tron, go. Huge data center. But I want to get like everything in one shot, you know what I mean? Like have that in the background and the other thing. I just don't know if it's possible to do that. It's definitely not. Wait, there we go. Now I got the whole data center in one shot, bro. We're really cooking now. Oh, not really. Anyway. Massive data center flex. How's the actual GCC compile going too? Slow. Glacial. You know when Jester 2 told me C is glacial compiles, GCC is the most glacial of all time, by the way. Perfectimogish. Alright, let's see what we need to do again. Let's see. So, let's log into the server. Let's go to, Todd Arch. Oh, let's go to Archman. I'm feeling, lucky. Go to C++ is a horrible language. Exterm. .NET Big Gay, Find Excel, and Main. EFI vars. Huh. I need to move the chat over here too, if we're going to be working on that one. Is that a dual GPU? Yeah. AMD RX 6500 TX. One of them I got from a friend, and the other one, boom, slapticate them in there. But that's why I wanted to get into compute, since dual GPU is pretty cool. Although I don't actually think it works. Here's why I don't think it works. And this is my new experiences in life. My newest life experiences say, if you install two GPUs onto one system, the CPU has to be able to be compatible with two GPUs. And even though I think that it is, I don't think that it does it well. And I think that's the case for most CPUs. It's also all AMD, by the way. Reboot dash H now.
36 gesture, 0 C++ 33M. C++, there is a much smaller and cleaner language struggling to get out.
Thank you, Bjarne Straustrup. Alright, then we're gonna go in there. We're gonna install base devel and some other shit. But let me get another one of these open. Oh. Okay, so I can only have one chat popped out at a time? What if I want to have 10 of them? What if I want 10 chats? I'm gonna be honest with you. This is kind of annoying because I want to be able to see my chat everywhere I go, but also at the same time, that doesn't really work. Site connection is secure. Because I want to be able to go to this window and still see what you guys have to say and not have to go back to this window to read it. But still. Thank you for Arch Linuxing. Thank you for choosing Arch Linux. Now, back to the video. Alrighty. We already did sudo pacman s. Yeah, sudo pacman -s base -devel get. Two things we need. We're gonna compile LLVM on this. And you could be asking, why not just download LLVM like a sane person? Well, who wants that when I could get Clang, bro, and compile it myself? The whole LLVM library is amazing. So what we're gonna do, get daemon user. Alright, we're gonna download get. Let's do get clone https://github.com/llvm-project.get. We might want specifically the Clang one. This is gonna take a minute for it to do. Cloning into LLVM project. Cool. So that's gonna take a minute. Probably. But while that's happening, we'll just keep reading through it. Targeting GPUs ISO C, C++. So here we have that, and they use pointers for them. Pointers for floats and int n for the number of iterations. Targeting GPUs C and C++ extensions. Cross-compiling. This is just cross-compiling. Plenty of build systems support this natively. A complete compiler toolchain has a compiler front end, an assembler, a linker, runtime library, but not runtime libraries. Let's port LLVM-C and C++ runtimes to the GPU. Huh? You mean like the fucking shit that runs the fucking code? Or wait, what are we doing? LLVM runtimes introduction. Bootstraps multiple libraries using just built Clang. Create the libraries for multiple targets. DLLVM runtime targets equals default AMD GCN. Oh, wait. Oh. Whoa. Oh, what? Dash DLLVM dash the runtimes. Triple var value. So then you could be like, oh, AMD GCN dash AMD dash AMD HSA. Clang LLVM multi-libs. Each runtime gets its own directory. DLLVM enable per target. Use the GPU target to create the appropriate toolchain. Clang will point to the appropriate folder. Only need to pass -lm and -lc. LLVM runtimes LLVM libc. The C library is the basis for other applications. The LLVM-C library is highly configurable. Just enable the functions we want and compile them. System calls are handled through the remote procedure calls. Client/server protocol, communicating through mutual exclusion. What's our GCC compile? How's this going? That's being handled by a fucking ARM computer. And then what's this doing? Still downloading? One gigabyte? Fun. So there's an LLVM library for GPUs. Let's go ahead and start writing out some code then. For this is the LLVM library for GPUs. That's also externed. So I figure we would use better C. We could probably just write it in D and use better C. Honestly, I think that might be possible. But let's look at what they include. I don't think they include anything in these examples. No, they just compile it. So we just have to write code and then send it over to the server, then compile it. Alright, let's go ahead and get started then. And I guess we could do it the right way and write it in C, or I could try writing it in D, and then just extern the whole thing as C, which is an insane idea, but we'll see how it goes. So if you extern C and compile it with better C compatibility, then it's literally just C++ at that point. Technically it's C. But that means it's, because it's written with D, it has features of C++, and it's almost practically the same at that point, but with, like, C-style, you know, actual machine code. But, like, it's got features of C++, it's weird, because it uses classes from C++, you'd extern C++ classes to actually use it. I'm getting ahead of myself though. Let's do let's create something like void dot underscore vec3 t to write a template. I think you still retain templates, so that's a good thing. Take that shit all the way down to the bottom right there. Alright, so void.vec3, and then you'll take t-array vec x and t array of its y counterpart. Underscore y. And then we'll have to determine if they're even. So if dot underscore vec3 dot length, or no, not that. If vec x dot length, let's make this return a value. It's got to return a t. So these will take t arrays, but it needs to return a t value of the same type. So that's what a template is. Basically, anytime I put a t, this is a value placeholder. And at compile time, that value is determined by the compiler, which is gonna be LDC. In this case, we'll be just using LDC today, exclusively LDC. We're gonna do it in a one-line if statement after we check the length. If vec x is greater than vec y dot length, or does not equal vec y is a better way of doing it, because then it guarantees that if vec y doesn't equal vec x, then they're not the same. So then what do we do? Well, we'll just return 0, because what else can I do? Return 0. So you can't take a dot value and return an array. That's what I would want to do in this case, is just return vec x, but that's an array, and you can't do that. So we'll take that. Let me see what's going on with my compiles and things. This is going well. C++ is a horrible language. Actually, I'll move the chat over to... Let's move the chat over to the other side. NVIDIA, explore the red key, explore the other side. Beep, 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 beep. Do, 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 do. Oh, wow. Wowie. Wow, that's enough. Cool. Alright, so that's the math we need. And the eval. So after that point, we need to get our dot value. So that's going to be the t, and it will be just called the t underscore dot. Actually, I'm going to get rid of that. That was a terrible idea. We'll call it dot. No, actually it wasn't, but t underscore dot, ta underscore dot. Maybe it wasn't a bad idea, but when you have like complex shit, you just need the simplest format of what it is. But I don't like that though. It's like I don't know. I don't like it. I don't like putting the fucking type in front of my shit. It makes it look disgusting, to be honest. People like to say you should put the type in front of it, but I don't think you do. You should do that. So t dot is just exists right now, but it's got to be set to equal 0 since we're going to be compiling that. So t dot equals 0, and then technically, instead of doing return 0, let's do t dot instead. Nice dual GPU PC. Yeah, that's the GPU server. We've had it in the closet waiting for us. the dual GPU machine. It's been waiting to be used. Let's see. T dot and then return dot. And then we have a vec y, vec x. What are we doing with those two? So the actual dot value is just a for each loop. For each index of vec underscore x. We're going to multiply it. Well, we're gonna multiply I comma mem. So that's gonna be a u long. That's gonna allow us to take a number for an index of it, of the other vec. Or what we could do instead to ignore like the slicing and things, to not do those, is do 0 to dot dot vec x dot length. That will basically do the whole entire thing. So then for each iteration, I'll just use I as an iterator instead, which is a simpler way of doing it. And then at the end of this, return dot. Pretty simple. Now, what is the actual equation in question? I wish I knew. I probably don't. Oh, hey, it's done. Alright, what's going on with LLVM today? CD into LLVM. Alright, let's get that shit trolling. I'm not sure what compile commands we'll need. Bruh. This shit's killing me inside. Please make it. Stage final. No rule to make target TMP. God damn it. Make clean. Bro, we got so far in the GCC compile. God damn it. I don't think this thing can compile GCC. The fucking Odroid M1S. Anyway, I'm gonna shut down all that shit. I don't need it running right now. And it's just in the background. Unless we wanted to do the whole video on that thing. Oh yeah? Watch me do rm-rf. Bing, 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 bing. It's gonna take forever. Probably. Return dot. What are we doing again? Alright, so for each of those, dot plus equals vec of x, or vec x and vec y. Vec y. Okay, there we go. That should be able to be compiled to C. Better C, specifically. And the reason we want this, we're going to declare this as a module as well. Module. Actually, should the module declaration be under the x turns C one? Module. Yeah, just call it a K-fish. I like that. That sounds cool. Module K-fish. Alright, we're gonna save that. Go to dlang, make a new folder. A new vector maxing folder. My longs to be long and unsigned. Long supremacy. Or you could just have bigger int. Big int 512. Kfish.d. Nice. Look at that shit. Alright, so I need to go ahead and see what's yeah, I'll figure that out later. Shut that down.
Too long to know C++ well. 36 Manchester, C++ 33M. Somebody from using C makes me feel like I saved a life.
Damn. Shut all of those down. This network is huge, by the way. Oh yeah. Just gotta do this 5 times in a row. That was setting up disk CC, by the way. But I need to compile the fucking GCC for it, which isn't happening on that system. I'm gonna actually, we might be able to do it on one of these. Alright, let me go ahead and unplug some shit. But I'm gonna do GCC on one of those as well. Oh, it's still on. That one's good. Bro, that thing's been cooking. It's been frying. I've been frying that shit over there in the corner, bro. That shit's been fried. Gordon Fryman. So we need to do some stuff. Honestly, I wonder if I could just... Well, if I compile it here, it's going to be compiled for this system, though. Would I really want to compile on one of these? So I could target the other one? I don't think I want that. Nice. Good stuff. I finally shut down that noisy ass machinery. That'll be a tomorrow this weekend whenever I get to it project. I like how I just extended it 3 times in a row. Alright. Wowie. I like that. Let's go ahead and resize this. No, too much resizing. Shut up! Window Manager has a very nice looking start menu now. Ooh. Bro, I think I like Cinnamon better than KDE. KDE! KDE! Why is this guy talking about KDE so much? Almost like he talks about garbage all the time. Oh. Oh, yeah, this... this, by the way. This one's hilarious. And it pops up so frequently. I think there might be something wrong with Gesture, that one always is popping up. Alright, so, we should be able to compile it using LDC. So let's cd into d_lang. And we're going to do some test run of LDC2 -betterc, maybe O3 in there as well for the most aggressive amount of optimization. So with dlang, it actually uses the C backend at the end of the day. Like everything compiles down to C in dlang. I mean, I think that's the thing for most things, but like with LLVM, it would probably change that. It'd probably everything compiles down to LLVM intermediate, which compiles down to machine code. So that's probably a difference. Not sure how that stacks in the long run. So, pretty interesting. ls, we have kfish.d. We're going to go ahead and do this. We're going to ldc2 and then -h so I can see what's available. C11, C99. Call the C runtime to assert the compile only, do not link, so C is good. You have O, like -O, but for optimization for size, OS, and OZ for size optimization. Equivalent to O3. I like how there's O4 and O5, but they don't do much past O3. And -O, equivalent to O3. -betterc, omitting this, generating some runtime information and helper functions. So all I have to do should be as simple as, and we're not going to do any of the spurv targeting yet, but we're going to try to get to a -O. LDC to kfish.d, and we're going to just put a -c in front of that. -c -O3 -betterc. And it compiles pretty quickly, actually. That makes a lot of sense. Now, if we ls, we now have kfish.o. So one beautiful thing you can do with a compiler like LDC2 is you can actually do all the linking with the compiler. All you have to do is call LDC2 and have your O file and your D file. So new, and we'll call this import. Technically, since we did module kfish, we don't need to import it. We can actually just call these as though they were like C header. Well, no, not C header. C header is different, but we could just, I think we can just call those. So we can do an extern block, extern C, since it's going to be using C ABI. And then we could call those from kfish, which, so we've just compiled a betterc template. with that, and we're going to call it with kfish. What is the function name? .vec. So we're going to call .vec. And then t.vec, and it's a template, so make sure it's a template. Although I don't think it needs to have that. It needs to be the same as it's in here. I'm not sure about name mingling either. Well, it's on the C backend. I think it will be fine. I think we can link to that. And then in our void main, import standard dot standard. Do I do the standard CIO today? Should I do that? Is that a thing that would be pretty fun? I don't think standard CIO. Let's just stick with what I think is okay. Standard DIO colon C teaser right there. Wowie. Right LN. And so we're just gonna do that. And then we're gonna call it in void main. So the extern C block up here makes this function and any other functions in this scope accessible, hopefully to the rest of the program. I'm not sure if that's actually going to make it accessible, but my hope is that it does. So void main will now be able to call that. And then we'll call .vec. Let's create two vectors. Let's call it vec_x and vec_y. Let's make those floats. And then give them an equal. And give them some numbers like 2.1, 3.5, 6.2, 7.8. Let's do another one. Let's give it a 9.3, 4.5, 1.2, and 3.4. Because I'm not doing pi. No pi today. So we have two vecs of a length of 4. We're going to pass them to .vec. Now .vec should be able to return a right line. So what we'll do is we'll do this. We'll do that and this. Simple, right? .right ln. Do the reverse function call syntax since I like to do that for some fucking reason. Maybe I'm a jackass, but that's to be determined at a later date. And now I should be able to extern C. Why am I saying extern C? Just pass the values. Vec X and vec Y. Alright, there we go. So that is the main. Alright, so we should be able to call from kfish into main.d without using better C. That's the thing. So we can still do O3, but we just can't use better C. Alright, so we're going to then do our linking step here with LDC. Let's call kfish.o and put main.d in front of that. So it should just automatically link them. Type double array to float. What? So it automatically says it's a double array? Well, what if that's a float? You know what I mean? What if those are all floats? I think that should work. Ah, right. Give it the C style. I don't know if I need to cast these. I don't want to cast them. That's fucking lame. Those aren't doubles. How the hell? Oh, right. We needed to declare them as float arrays. That's what it wanted. Multiple lengths. I'm getting roasted right now by Jester. I swear to God, this works. You know what? It's fine. I'll just declare it as a double. Why not? Sure, I guess that's the most optimal format. I mean, I guess it would be. Okay. Oh, right. We had to compile this shit too, don't we? Let's run... Oh. Let's go read the shit we need to read about it. Like, do I need to do anything special? So, here they said cross-compiling LLVM multilibs. Each runtime gets its own directory. LLVM runtimes, and then... Alright, cool. -D LLVM enable per target. LLVM runtimes introduction. Create the libraries for the multiple targets. CMake arguments can be passed directly individually to each runtime target. Okay. Oh, but that's for CMake. But, well, I mean, how are we gonna get D-Ling to do that too? That's like the question. 'Cause what if I don't want to write C? I mean, I could write C, theoretically. I mean, what I just wrote, I could probably reverse that and put that into C. I did just extern it as C too. C 2.0. Anyway, CMake. I hate C++, by the way. Dash runtime targets, and then, of course, alright, so here we go. Install. I wonder if that's gonna help it. CD into Clang. Right, so I could write it in, I'd have to write it with Clang, compile it with Clang, and then pass it to the thing. Or with Flang. Which, AMD has their own version called AMD Flang, but there's also OpenMP in there. CMake list.txt. Oh, maybe we do run autoconf? Okay, here we go. But what if we want an LDC compiler? You know, like LDC? But that's built off of LLVM backend, right? Shouldn't it just use Clang? So how does the LDC compiler fit into the picture then? That's the real question. Like, where does LLVM fall into, or LDC fall into the LLVM circle? So LDC 2, how does that end up? LLVM decompiler. Oh no. We're gonna download it and set it up ourselves. Building from source. If you have a working C++/D environment, CMake, and a recent LLVM version, around 18, available, there should be no big surprise. Do not forget to make sure the Phobos submodule is up to date. Okay, so DMD, GDC, and LDC are supported as host compilers. For bootstrapping purposes, we recommend GDC via its GDMD wrapper. Yeah. Cross compilation. Very similar to other LLVM-based cross compilers. Cross compiling with LDC is simple. For instructions, yeah, that shouldn't be hard either. So like, what I'm curious about. Wait, do they have Arch in this? Arch Linux, bro. Arch is like the best one, by the way. I'm just saying. Just saying right now, Arch is the best. So compile LDC2 with Clang AMD GCN backends. Appropriate LLVM libraries. Configure LLVM with AMD GPU target. First, ensure that your AMD Clang build includes the AMD GPU target. When building from source, use the following CMake flags. This will make things a little easier. Type release AMD GPU and just target AMD GCN and AMD HSA -G Unix make files. Alright, so we'll do that. Per DLLVM enable so you can do default semicolon AMD GCN AMD HSA and NVIDIA CUDA, which maybe I want that, sure. So that's our LLVM runtime. So we're gonna CMake that. But we also need to do -G. Also, whatever this says, runtime targets to build AMD GPU. So let's do that. This is for the runtime though. That's to get the runtime. That's what that presentation is about. But this is for Clang to have the things. But we need to do, what was the again? Pretty much dash DC make build type equals release, dash DLLVM targets to build AMD GPU, and dash DLLVM runtime targets equals AMD GCN and AMD HSA. Right. Equals default NVIDIA PPTX. Is that put in quotation marks? Yes, it is. Okay. I would have thought the LLVM guide was doing it in an interesting way. You could technically do it with default. So that's the runtime targets for AMD GCN, AMD HSA. Cool. And then it wants a DC make build AMD GPU and then so on and so forth. So is it dash T target to build? Bro, I can't remember these. DLLVM targets to build equals AMD GPU. So DLLVM targets to build equals and then put AMD GPU. I'm pretty sure it's all uppercase. And then DC make build type release. What was that? Underscore. Oh, these are underscores, by the way. Let me verify that I did that all correct. I need to put underscores between those and then dash G Unix make files. Dash G, is it capital? Unix make files. Should be what it needs. Ah, capital make files. And also the release is in quotation marks. That's gonna be two deduction rake files, make files. Wowie. Oh, look, it doesn't work. No surprise. No source or binary detected or provided. Oh, I know what that means. It wants a /. Are we building Clang, though, or the back end? Because LLVM should be the back end. Yeah. And then dash B. Ah. Let's see. Let's do that. Let's do that. Yeah. Alright, so we need to do the thingish cmake-s, this directory. And then the target directory. Do I have to make a directory? Did it make a directory for that? -b llvm project /build. Or ./build. I hope it doesn't need like a static path. Does not appear to contain us. Is there a config? Does not appear to contain that. LLVM libgcc bolt clang cmake. It's LLVM cmake. Alright, let's cd into clang then. But that's not the correct one, maybe. Maybe I didn't download the correct variants. LLVM project /LLVM. Oh. Of course. Alright, so then we just gotta do this, but then again. Building the backend. How K Serioso Amogus can I get with this one? The build files. The ones that I hope aren't redacted this time. Alright, so it should be pretty much just cmake. Cmake is done. So now we need to do make -j and then do our nproc. I think that's what it needs, but I'm gonna hold off until I make sure that I'm doing it correct. Sure, why not? Build LDC. So we'll do that first. Using the following cmake commands. Build LDC. You must pass the path to your LLVM installation. Ensure that AMD GCN backend is available. You can verify supported by checking LDC2-version for the GCN. For the AMD GCN GCN GPUs entry by passing registered targets list. So, do I need to get LDC2? Alright, so then do I... Well, maybe I don't need that. Use LDC to compile dec... This is not gonna work. I have a strange suspicion this is not gonna work. I fucking don't even know. Goddamn, if this works. So we need to download, I think, the directory for, well, I don't know, when building LDC, so we're building LDC. This is what I think we're doing. So what we're gonna do, we're gonna download LDC, right? So we're gonna get this repository. We're gonna get LDC developers /LDC, right? LDC beautiful. Is this LDC2? Oh yeah, last week updated. Hell yeah, I like that. All right, so that's what we're gonna do. We're gonna git clone LDC. Actually, it might even have this LDC2.git. Honestly, I'll just copy that shit. Copy that to clipboard. And then let's not make it yet. Git clone but my question is, do I build LDC2 or do I first make that? Okay, so maybe I need to build this. Build LDC. But maybe the information I need is here. So to build it, building from source, in-depth material on building and installing is available on the project wiki page. Linux, macOS, and everything but Windows, and then Windows. Everything but Windows. You could just sum it up as everything but Windows, and then Windows for the outcasts. The fucking outcast OS. CMake and a recent LLVM version. Alright. Do not forget to make sure the Phobos submodule is up to date. So cd and then git submodule update init. So, but I need that up to date information or that advanced. Oh, click on the fucking circle to continue. Thank you. I'm sure that circle is very fucking. Alright, it's hard for us to get these. If you run into trouble, have a look at the build scripts for our continuous integration platforms. Thank you. A C++ toolchain, GCC or Clang, a decompiler, DMD, GDC or LDC. Ninja, get shit on. I like make. Because make is what Linus Torvalds would probably use. But no, actually, I don't know. What would Linus Torvalds use? I don't know. libcurl for Phobos. The minimum is 15 using a pre-built distro package. Building from source. So that's how you would build from source. tar-xpf. So you would get your LLVM projects, releases, download, LDC. So you would do cmake -g ninja. What? We're not doing that, but that's how you would do it there. Of their slightly tweaked LLVM. So that's going to make their LLVM version interesting. Build and install. We're going to try building it with the backend. Okay. So build. Okay, we can do the make-j nproc and then install. But I'm not doing that. I'm not installing that. We're gonna just make it. And then we'll do make install. I think. Let's see what's going on. Anybody sending chat? No chats. Good. I don't want to read chats today. Me, I am going to not git clone that yet, because we're not there yet. We're going to do make-j nproc, so that will use the maximum number of processors. Did I not just make a makefile? Where's my makefile? CD into build. Then I can run make -j nproc. Alright, this is gonna take a while. Wowie. I don't have an LDC compiler installed, by the way. Building CXX objects. I'm sure it will explodicate. But yes, we like to compile on this channel. We are compile maxing. Hopefully this doesn't fail. C++ is a horrible language, and watch how much C++ is in here. So basically the entirety of LLVM is written in, well, for the most part, it's written in C++. And I hate C++, but I'm a keen dealing enjoyer, which is like the most anti thing of all time. I don't know. Damn, bro, those fans are going now. It's almost like compiling LLVM on one machine is a bad idea. Maybe I need 3 or 4 participant machines. Or precipitant machines, you know what I mean? Precipitant? It's a funny word. I don't know where I picked that up from. Micro Rust. Micro Rust. So what's the problems here? Control save that. Thank you, Jester. Jester, C++. Whoa, that shit's hella going. Hella compile right now. Bro, that shit's loud, bro. It's cooking. I call that computer comrade Kuknikov, and he's cooking today. At 500,000 degrees centigrade. I mean Kelvin, since they use Kelvin in Russia, bro. Kelvin maxing. Main.t. Identifier expected to be for template parameter. Get shit on! What if that's a template? How would you extern? I've never externed a fucking template before. What? Oh. I know what I'm doing wrong. Also, the machine just stopped. Bad sign. Oh. Hey, maybe it was just doing a lot of linking? Does C++ have a preprocessor? I don't know much about C++, but I don't think C++ has a preprocessor. I read a lot of LLVM docs. We should probably just do videos where we just go over LLVM. I feel like it's like one of the most interesting things, and it's one of the most versatile tools out there. That's why I like it so much. But then again, I don't know how other people feel. Let me know what you think about LLVM while I'm programming and not downloading stuff and then making it in CMake. Beep, 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 beep. So that's the... Okay. Okay. T for type of. Type of. Let's do that. Then let's just make it extern as t. What if I make dmake? You know, like cmake's cool, but we need dmake.
Gesture. 0 C++ 33 in. C++ is to C as lung cancer is to lung.
Thank you. I needed that. I always knew C++ is to C as lung cancer is to lung. Oh my goodness. Oh, it's 4 a.m. What? So maybe because we're using extern C. When does this happen? That's on 10 and 11. Okay, what about 12? Double. Because it's passing them as doubles? These are double arrays. Oh, that's why. I'm just fucking stupid. Me, I am stupid. It's been like... That's what I'm doing wrong. How did I mess that shit up?
Is not overly complicated. Just what is a protected abstract virtual-based pure virtual private destructor, and when was the last time you needed one? Tough cargo. 0 M.
You need to pass them as pointers to the actual array, more than likely. So in the function template, you would use a pointer. Let's do a t pointer instead. I don't know if it needs to be a t array pointer or just a t pointer, because d arrays and the other thing are not necessarily compatible. Main.o and function dmain. Main.d undefined reference to float. Float pointers maybe don't work very well in this case. Maybe not. Maybe it doesn't want pointers. What does it want? It's technically a C template, so. But maybe it's also because you can't use templates in better C. I don't know. Maybe that's a thing. I think it's possible to use C templates. The make files. This is actually a pretty fast compilation. Maybe we'll be able to compile GCC compiler with that. Let's see. -c kfish.d-03. Because it's trying to link it. Undefined reference to main.vec. We'll also need a regular LDC compiler too. But that we can download that one on the thing. The only thing we need to compile there is this. And then we're good. To main.vec. Undefined reference to main.vec. Float array. Let me read the docs for. Yeah, give me a better C documentation. Better C. Better C is a subset of D that doesn't depend on the D runtime library. The main function to be written in D to ensure that the required runtime library support is properly initialized. To link functions and libraries into C programs, it is necessary to only require the C runtime library to be linked in. This is accomplished by defining the subset of D that fits this requirement called better C. But I want to know about the retained features. Here we go. Should be templates in there, right? Full meta programming facilities. That includes templates and unit tests. And so running unit tests, unavailable features. Let's see if templates are explicitly listed here. No. So it's really weird. I'm not sure why, though. Maybe I need to understand C-lang templates. C meta programming. Meta programming as in Mark Z. Zuckerberg. The Zuckerberg. You guys know about the Facebook files? The meta files or whatever? Facebook files. Code that code. He's not wrong. It's code that codes. Andrei Alexandrescu. The C programming language. C programming. Yeah, programming. Linux. So, how is it retained though? I mean, I guess it would just be the compile time features of the compiler. So it's not a problem with the this. It's a problem with how I wrote it and what's being passed and how. I think it needs pointers. Maybe address pointers. So those, I hope those work. How's this going? 78% complete. Fantabuloso.
36 in Chester, 0 C++ 33 in. C++ is more of a Goldberg type thing, full of high voltages, sharp edges, exploding widgets, spots to get your fingers crushed. And because of its complexity, many, if not most of its users don't know how it works and can't tell ahead of time.
Yo, what's up? So we just gotta pass these as pointers, probably. That one, and then that one. Ah, yeah, those won't pass unless you pass them as a. I love my TGS just yelling at me that C++ is horrible. It helps me stay motivated. Let's try casting to float pointers. I think it might be this might help it. I don't need to do that one, just this one.
Chapter 0 C++ 33M. C++ is the worst to be taken seriously. Where does PHP fit in? Asking for help.
Yeah, that's a good question. Where does PHP fit in, by the way? PHP is like the evil Zuck language. That's what Mark Zuckerberg started with. Adding time to your taskbar. Make it GPU accelerated time. With all the GPUs that NVIDIA has, then maybe they can make a time machine. Then, lol. That compiled, but then we need to pass these to this. And because it's better C, we're trying to pass this to a C template, basically. A template, but it's C. And so, passing that, then here we go. Main.o in function D to main.vec. So undefined reference to that. Maybe, just maybe, I declared it wrong, which might be the case, and putting it in the scope was a bad idea. So if we extern C here, does that do what I needed to do? Now, if I were to compile it normally, it would definitely just work. But you'd have to import... Well, you could set it as a module. What if it's just that it's underneath this? No, that doesn't matter, though. That doesn't matter. Literally, that doesn't matter. Since D has selective imports and shit. So you can be, like, within a scope and have an import in a scope. Then it states that technically you could have... I think it's just that I'm trying to interface with a better C template, and then the better C template's frying my brain cells. I'm not handling the information we're passing to the template correctly, and it actually needs pointers. But let's see. Let's go back up. They should have a section where they have support for all C types. Pointer conversions, data types, delegates, special cases, no. Import C code. Oh, whoa, that's where you compile C code with one of the decompilers. Demo.d. What's going on with my compiling? It's probably at linking. GNU is not Unix. GNU is not Unix. Guys. GNU is not Unix, by the way. Awesome. AMD GPU. Import C. So what is import C again? Extern C. All symbols are extern C. So better C is a subset of D, and then import C is There are many versions of C. Import C is an implementation of ISO IEC 9899:2011, which will be referred to as C11. References to this C11 standard will be C11 followed by the paragraph number invoking import C. The import C can be directly invoked via the command line or indirectly via importing a C file. So you could import a C file into D-Lang, and then a .i.h, which is header, or C for C. Will compile hello.c with import C. Alright, let's move back to the this. So we have that now. We have our LLVM build target LLVM-reduce. Sorry, ls. So we have that in build. So we can do make install to get our LLVM backend, or we could do that ourselves. Let's investigate. So the minimum supported version is 15. Make install. For more CMake variables, if you're planning to work on LDC itself, there's the dash d CMake build type equals. Now that you're ready to build LDC from source, clone the LDC repository. Okay. Build LDC. Install LDC to CMake prefix directory above. Oh. We also needed that too. Because that is, yeah. This. What is PWD again? What is that? That's something I'm curious about. Nice. How about writing in Holy C? I have Holy D. Nice. Even though Linus professor that named Linux for Linus Unix combined, Linux can also equal Linux is not Unix, or Linux is not Unix. Oh, damn. Just like GNU is not Unix. I thought it was an interesting thought. I think it's just that he combined his name with Unix, honestly. well, somebody else did it. It wasn't him who did that. I think it was somebody else. I don't know if he named it or if somebody else did that. I'm not sure. We probably should have passed that to CMake before we compiled it. Oops. So, I'm guessing that because I didn't run install, it should be fine if I just copied it. But I don't know CMake very well. Make install. I'm unable to understand the process of installing software in Linux and Windows when we run an oh my god, bro, Windows, yeah. Make is a general purpose workflow program usually used for compilation, but it can be used for anything. When you do something like make all, the make program executes a rule named all from a file in the current directory named the make file, which is made by CMake in this case. This rule usually calls the compiler to compile some source code into binaries. when you do make install, the make program takes binaries and from the previous step and copies them into some appropriate locations so that they can be accessed. Unlike on Windows, installation just requires copying some libraries and executables, and there's no registry requirement as such. In short, make install just copies compiled files into appropriate locations. Okay, that makes sense. So I didn't specify what the location is, though. To figure that out, what I'll do is I'll cat it and I'll pipe it to grep for the make file. Cat cmake install distribution, install LLVM. OCaml. Yes, OCaml. I love OCaml. We might want to recompile that and pass the -d cmake or install location. I don't think we want this as the main build. Unless we compile against this? What do we do? Do we compile LDC against this? Because if we can do that, we would just pass this into the make file for the LDC. Let's see. I love documentation. It's sometimes you just read it and then your brain fries. For me at least, my brain is on fire. Equals release. User, we'll just do home / LDC. DD compiler. Oh, okay. So if the host compiler is found, it won't need that. LLVM rootdir. Not needed if using a distro LLVM package. Ah, that's what we needed. This is perfect documentation. It gave me exactly the information. Brilliant. Alright, let's do some things. So we're gonna copy all of this. ls, right? Where are we at? We're in build. Which is underneath. What the hell is // ls? Let's see. There's OpenMP. We might even compile that today. I mean, technically, this is all just gonna compile into the same. I'm sure it's not gonna work though, because this is all theoretical. All right, so we're gonna copy that. Actually, let's MV that, and then do to GPU backends. Alright, so now that should be moved. That's the GPU backend that we need, that I just compiled. Now we need to git clone https://github.com/ and let's go find out what the rest of this is. LDC to developers ldc.git. Brilliante. And then we're also going to clone. We don't need to clone anything else. We also need to do sudo pacman -s afterwards. Alright, that's gonna take a minute. It's not taking too long though. Alright. That's pretty tiny. LDC compiler, not bad. Sudo pacman -s. Let's go with LDC to it should just be LDC. And they say once you're in there, you should here's all the stuff we need. And they said you should, when you link against the library for Phobos, you need to do some stuff with that. So down here they specified to get submodule update -- init. Alright, cool. So we're on the latest versions. Ready to compile things. Alright, so the compilation procedures here, we're going to do the following. We're going to make a directory and then cd into it. Alright, that's why you always do that. Alright, so we've done that. Then we can run the following: cmake ... which is going to put us in the other directory. Unix makefiles. I'm loving my Unix makefiles, by the way. Okay. Is that how I did the previous one? Let's see the previous ones. Yep. Unix makefiles. This is gonna be fun. This is gonna go so wrong. I don't think this will work. There's no way it's gonna work. We're literally compiling it and setting up its backend for the compiler itself to just be set up so target fucking AMD GPUs, and it's dealing. I don't think it was meant for well, if we're compiling it with LDC, you think that the intermediate representation, the LLVM bytecode and all of that will create the correct Frankenstein for me to run decode on GPUs. And then we'll create the incarnation of, I don't know, D-Jesus. Who knows? This is insane. Ah. /LDC. Build-LDC. Okay, so we need to cmake --LD .LDC. LDC, and then Unix makefiles. What was the other stuff I had to pass? Bro, I'm a hard time remembering this shit. You want to pass DC make build is release. Then you're gonna pass another one called DC make build prefix install LDC. That's not required. That just tells it where to go. But we'll just put it into home and then put it from there. LD Stein. LDC Stein. Actually, no. Just put it into home. Let's just do a make dir in the home called LDC Stein. Frankenstein's monster right there. And make. So now I'm doing both. Ah, look at me writing one-liners, hopefully. Hopefully not to exceed one line. Alright, that's the prefix. The prefix is good, right? Prefix is Amogus Skibbity. Then the next one, the DLLVM root dir, which we'll have to pass as home / whatever path I put it in. Which is, I think LDC backends. GPU backends. I think that's pretty much everything it needs. And then it's going to fail because that's not the correct path. And then lastly, the DD compiler, which is going to be the latest LDC2. Which should just work. Let's see. Everything looks good. Nice. Wow. Let's see. I'm kind of worried. Of course. Good thing that's the first mistake. Bro, how far do I have to go in this line? LVMD. Oh, cool. Holy shit. I thought it was gonna miss the one thing, but so it needs a path to my compiler. ls Oh, okay. So here we go. But that's not needed unless you have the LDC compiler in the thing. if host decompiler is found in path. Let's see, I don't know if that's set cmake ldc2 compiler. Cmake is so cool though. Like, you can literally write out a script that makes a file for somebody. That's like the thing I like about cmake. That's why I like it. Because it's like, you write it out, you don't have to be like, we have this build tool called DUB that just does fucking whatever it wants. Project. Wait, you could technically write a cmake file that does just LDC. cmake decompiler. Set to LDC2. Okay. So you just need to pass it as just LDC2 caps. Configuring errors found. Could not find compiler set in variable decompiler. I just want to use the system default one. The default one. Control copy that, because I have no idea what I'm doing. Copy selection clipboard. Paste that shit in there. Solve my problem. Instant gratification. Activate. I'm not writing the cmake file. Ah, thanks. I don't know how I didn't know this shit. That's something I should memorize. User bin is important. User bin, always good. User bin for the win. Oh my god. Try LDMD or GDMD or set compiler ID manually. Wait, did it say something about uncaching it? Hold on, maybe I need to run cmake clean. Cmake clean. Clean maxing. Wowie. Ah. cmake cache. Goodbye. You are become destroy. The make files now. Let's go ahead and activate the make files. Try LDMD2 or GDMD. Or set the compiler ID manually. Fuck! Alright. Sudo pacman-s. Let's try LDMD2. Awesome. Or GDMD for GNU DMD? Oh, not that one. Or set the compiler ID manually. What am I doing? Let's see what's going on. Almost 40 commits to my OS. Good job. I also once used to commit a lot, but not anymore. AI, check this debug and solve it for me. You have 5 minutes to do so. Time now. Execute. Instead of LDC2, the LDMD2 script is the standard driver for LDC next to the DMD, but install along. But it's typically installed alongside LDC2. Okay. Sudo Pacman, my DMD is okay. Wait, so you need LDMD? Whoa! Holy shit! CMake warning. Configuring incomplete errors occurred. CMake error. Utils. File.intrinsics not found. Including compiler RT libraries on dash not found. Clang unknown. Asan. LSAN, MSAN, TSAN, built-ins profile, expected compiler RT directory. Does not exist to include PGO sanitizer spore. Linking it to trying to compile this with the backend for AMD GPU was probably not a good idea. You know, I kind of knew that from the start. The ASM compiler, GNU, blah blah blah. GDB 1.17.2. Configuring incomplete errors occurred. So the errors was this. Not found, not found, not found. It's all Clang 24. Including LLVM on... I wonder what this even means. I know it just means that it didn't find them. Inlines hidden flag success. You know what's probably going on is the LDC compiler probably there's probably some weird architectural mismatch with this with the code we made for that and what we're trying to get out of it. What an interesting thing I discovered. Grok bug fix, then force push main. Alright, now let's go ahead and feed the robot this thing. Take my error log and make it simple again. I hate reading this shit, it makes my eyes burn. Can you explain it in 10 different ways? Intrinsics. This usually happens when it points to an installed that lacks the necessary include files, or when LLVM source directory is not specified. To the LLVM source directory, not just the install prefix. To your build source or directory. Root dir. Oh, okay. Wait, did I do that? Didn't I do that? Yes. But maybe it needs home Heisenberg thing. Actually, a better way, you could technically do that should do it as well. Not found. Let's remove the cache. Let's try it again with this. Still cannot find it. Alright. So that didn't do anything. if the installed version at try set to your LLVM build or source directory. The target architecture suffix. Oh, yeah, this makes sense. If you do not need sanitizers, disable the check. Sure, that's a good idea. You know what's going on here is that I've compiled something for a GPU backend. So first of all, the reason it's not working is because the compiler expects... This is exactly what I said. Architectural mix match. Literally, fucking exactly what I said here. Alternatively, explicitly set the path using missing LTO plugin LLVM gold.so. Ignore if necessary. Link time optimization. Oh, shit. But we want that. It's fun. It's fun. DLLVM bin utils inkter. Okay, this is runtime libs off, but that does make sense. And they talk about it here, LLVM runtime libs. So enable per target runtime dir on. Let's see. But they also have other information like runtimes. CMake arguments can be passed individually to each runtime target. Triple value. So then you'd have to compile it with libc or something in one of those ones. So that's the compiler RT, the libc. So we need to redo all of our compilation in the previous one. Let's go ahead and go back. So cd ... ls rm-rf, and what's it called again? It's called the GPU backend. Actually, yeah. Remove the, we'll remove everything inside of it, and then we'll cd into LLVM project. I think there's a LLVM folder in there. Directory. ls, there should be one called build. But we moved it, so mkdir build. And then cd into build. We're gonna redo the compilation. I'm gonna copy this whole thing so that way I have it, and I'm just gonna take this real quick. That is one hell of a line of one hell of a command right there. Bro, how am I gonna copy all that? This is why you break it up when you do these. Yeah, never mind. And let's use our this, so find the right one. not those. We should have all the commands in here, so we'll just be able to redo the same steps. Runtime targets. So we need to pass runtime targets correctly this time. The AMD HSA, you can d-runtimes, so when you have the runtimes, triple var, so a triple and a var. Oh, I guess the triple would be like x86 or NVPTX or something like that. And then the runtimes, you could have a var? What? Let's see. Let's see what this gets me to. Pass them? How do you pass them though exactly? D runtimes underscore AMD GCN dash AMD dash cache files enables runtimes per target, which is exactly what we need. That has pretty much everything in there with the C ABI, C++ ABI, and should have everything needed, I hope. So all libc++, libc++ ABI, compiler RT, and the libc, which we were missing the compiler one, so that's pretty good. Let's dump that in there. CXX, that's pretty much all of the runtimes for AMD GCN and AMD HSA. So hopefully, we can just pass the pass that to build. Hopefully this one works. It looks like it's gonna work, but if it fails, we'll find out. Oh, make error. Errors have occurred. What's the error? Perhaps it has not yet been created yet. cd ... Try it with the -s for // and then -b for build. That's what I'll do. -s. And then -b for build. Looks like it ran into errors again. Fuck. External project. It has been created. Call stack, most recent. What's in here? Okay, maybe we need to remove the I mean, it should have worked. I think it worked. Targeting AMD GPU. Users share slash CMake slash module slash external project get property. Call stack, most recent call first. Get file deps. And then LLVM external project add. I don't like that. But then it finished. Let's see. I don't know what this could be, but what language is this, bro? Well, this is D, but I'm trying to compile the LDC compiler with a GPU backend. Very interesting. Shove the cake. And I figured out why it didn't work, because I didn't put the runtimes in. So I found this yesterday while I was just bored and looking around for something interesting. And so I found information about LLVM, one of my favorite compilers of all time. And, oh, maybe it needs OpenMP as well. I wonder if it needs OpenMP too. It might need OpenMP. Oh, we'll figure that out. Oh, but that would be good. Offload. So OpenMP is actually a better option than just AMD GCM. The Clang project, which creates this target, is not being built in the same CMake configuration as the runtimes. Primary cause and solution. Clang slash CMake lists. Dot text. Separately or in this. Oh, but that would build the Clang, wouldn't it? Wait, so targets to build host and then default enable projects Clang and LLD. Wait a second. This is interesting though. What if we just copied the correct LLVM version, or no, the Clang version into. So we could just move the LDC version. We could move that whole LDC thing we just made, copy it, then we can. We're good. It's like magic. It just works. It's kind of interesting. Ensure that Clang has been included in the LLVM enable projects variable. The runtime's build often relies on just built Clang compiler and its resources. Do I have Clang? I guess we'll just add this to it then. Add that to my command and see if that works. That is what I will do. Just append it to the end. Okay, that's a warning. Okay. No errors. No errors. Yes. Oh, that's good. I hope we're not building a Clang compiler. I don't want to build a Clang compiler. I want to build a backend that way I could build LDC from it. Alright, and then we just gotta run make-n, or make-j, and then the number of processors. I will have to go take care of something real quick. Oh, wait. CD into build. And then, yeah, I gotta take care of something, so in the meantime, enjoy this while it builds. I wonder if it's gonna fail. I don't know. We'll see. If it fails, then you guys have like some time to read the fucking shit before I get back. You know, I just realized I need to put my shoes on. Oh shit. World's greatest streamer of all time. What are we looking at? It's 25% complete with the compilation. Very good. I hear it going very hard. Let's see. So, I wonder, what if we just made our own compiler at this point? We might just need to do that. You think you could target with the Spurv backend. Let's see what's going on with the better C though. Oh, you know what's gonna be interesting though? Is once we get the compiler up and running, I wonder how much it's gonna break. It's guaranteed to like break in some way. Like it's only gonna target GPU or something. I don't know. I could do all this talking about it for hours, but you see, there's all this talking, and then there's not a lot of doing. If I'm talking about it, let's see. T.vec, T of array. Type array. Okay. Type arrays. How would I extern these? Because you would need it to be a T template. To undefined reference to main.vec. Returned with one status. LD returned with one status. I think it's a linker problem because they can't link. Something wrong with linking, but let's see. Main.o function dmain. Undefined reference to main.vec, so like inside of the main function, a .vec, which was the .vec3. Ah, we didn't put the correct name. That makes sense. Now I should be able to do that.
36 Manchester, 0 C++ 33N. C++ programmers prefer dark mode.
I don't know why it's called .vec3 because it's a vec2 technically. Technically, it only will work on a vec2, two-dimensional vector. Let's recompile that and try this out just to see if we can get a better C. Main.vec2.
Jamming a helicopter inside a lighter and expecting some sort of improvement.
Let's try compiling without -03 to start, but leave it as better C. Let's do the LD step manually if this fails. Alright, let's do the LD step manually. Alright, and then, so now it's externed. So we created a .o file for both. We don't need to LDC, we just need to do LD. But we should have LLD too. Which is the LLVM version of linker. And kfish.o. A lot more. We are dealing with name mangling, I think, in that case. It's better to try it like the other way. So that one, and then this one, 03, but let's get rid of the 03 portion. So an undefined reference. However, these are declared as extern. That's the voice of Eric Nagum in Roboto mode. Good job, Mr. Freeman. We are compiling AMD GCN. And then I want to try the OpenMP version. Maybe tomorrow we'll try, if we can get it to work today and we compile it correctly, try the other version. Grockenheimer. What if... Are we calling it correctly? What if it's a reference to it being... It's a return type. Let's just try returning a float. Float res equals .vec res dot write ln. It's probably
going on here, and I've yet to see a counterexample other than possibly a few of the members of the Standards Committee. A Sylvan in Reddit. 0N.
LDC, let's see, link, better C, and D-link. I want to see if there's any examples out there, bro. Examples? That's how that works in better C mode. That's how it does. It's intended. If you do dash better C, you're expecting the news Y Combinator. I like Y Combinator. They're actually pretty decent, I think, at news. Hacker news, bro. Hacker news for hackers like me, bro. I'm an evil big bad hacker because I write and do. Fuck you and fuck your Rust, bro. Get shit on. Congratulations. I hate Rust, and the second I see it, that's all I'll be doing all day. Compiler, better C.O and dlang.d. Yeah, we've already done that. What's this say? Better C linking. I wonder if it's a name mangling thing. We could figure that out with NM. It would give us a bunch of names. So we would do, the previous code we had here was fine, obviously, but let's try NM, which is name mangling, -H. It will give us a list of all this. And I've used this a few times. Debug symbols. So let's do NM dash A, and then our O is kfish.o, kfish.d. Huh. So it fails to compile and doesn't return an error at all. What? So let's not declare it as extern C, and then let's try compiling it again. kfish.d. Okay. Interesting. Maybe I'm doing it wrong with this, though. And you'd use -C to name, demangle. There's also obj dump, which we could use. So if this isn't working, let's try obj dump. H for section headers. Text, comment, note. Alloc, load, read-only, and code. Contents, read-only. And then there's one for symbols, right? File headers, archive headers. -T for symbols. I like digging into programs like this when you just compiled it and then you're like, df abs elf 64x. That's correct. I mean, I wouldn't expect that to be wrong. If that was wrong, something is very bad. But I wonder if there's a source. Like, what does -S do? Oh, okay. That explains it. Oh, isn't there one that disassembles? Yeah. Display assembler contents of the executable set. -S. Let's try that. Oh, it just has a file format and that's it? And it says... So there is no symbol that we can disassemble. Oh wait, there is. Here we go. It compiled to add and... Whoa, this is hella cool. Holy shit. Bro, I'm disassembling program. Oh my... Brain cells, bro. They're leaving my body. They're leaving my body rapidly. What the hell? I didn't know this was a thing. So look at this shit. I can learn assembly by disassembling my D-Lang program, which I externed better C. Look at that shit. We got 00, 6C, 64, 63. Bro, this tool is fucking awesome. I love OBJDump and NM. They're my favorite tools. And you can see we got a %CHR, and then we got this, or %CH. And that's a register of some kind. But that wasn't even with -03. Let's try compiling with -03. Optimization level 3. I want to see what LLVM translates that into. I wonder if there's a difference in instructions. So let's see. -kfish. What did I do? -d? Yeah, it's basically just the same thing. Pretty much. Not really much of a difference. It just defaulted to like the max. Well, there's no max. But the problem is that there's no like actual name of the section or something. It's called a dot comment. So in dot comment you have add and jump back or jump by, and that's a loop. So that's a loop right there. Then you have imul, XOR, and XOR. I don't know what imul is, but I know XOR. It's XORing the register RSI, and there's also a register RAX, which that's a one I'm familiar with. RDI? I don't know what these other ones are. I have no idea. And then look, there's an integer value or something at the end. I can't really read that. It's kind of, but like, wow. I just disassembled code. He's a hacker. That didn't help me though. So let's compile it as a better C. We're at 56%. I'm a hacker, man. I discompiled my code. I discombobulate my code. But then that, you know, if I do objump-d, now you see name mangling exists. So here we have D5K fish 12 module info. So if you were to link that, you would need to have that in there correctly. What are these? What art thou say? 0%. I think you need to... Oh, and it's got a dot byte section. Okay. Let's extern C the program. Put an extern C label. This is standard in LLVM. You actually can do that with the API. So here we have this, but I'm gonna recompile it to better C. LDC2-C with optimization 3. OBJump-D. And what changes happened? There was no changes. And I think one way we can make it better is that like we could technically inline this. Technically inline 86. But that's really interesting because damn, like this is so fucking interesting. So the first one is like an instruction. So I guess 00 is AND. Or maybe that's 6C. Damn. Oh my god. DH. Oh. and the name gets turned into that. I think it's the same on that one. Yeah, so that's actually an address. That's not a name, that's an address for 0x34. On this one, it's 0x34 as well. I guess that might be just how the name translates down. I don't know. I'm not an assembly guy. If you know what assembly is, please help my soul. My kidneys are not made of assembly code, but my brain might be. This is such an interesting episode of Fish decompiles his code and trying to figure out why it doesn't worky. But I think it's something to do with linking? Maybe it needs a module name too? Does it want a module name? Kfish dot, no, semicolon. Let's try that. Try recompiling it with that. But it's in dot comment. Why is it in dot comment? So like what? Dot comment is just a random... Does it need to be declared as int? Or like void? Void t. But let's write something that I know it will work. Let's say we had void and let's say we don't have void, but we have I think it fails. That's what this is. But that doesn't look like it failed. It looks like it got through most of the assembly step. Let's say float and then float arrays. Invalid array operation. Ah, caught it. Perfect. So the template doesn't throw the exception that there's a multiplication of two arrays going on. T T T. We are going to return a T. Oh, you can't return a T? I see. Okay, this is an interesting thing. I wonder if Better C should have the compile time stuff, or the fun stuff, the stuff that cooks, the templates. Use templates in Better C subset of D-lang. Alright, verify it. I'm not, okay. I'm not a human, by the way. If you guys didn't know, that's why I'm awake all the time. Well, all the Better C is designed to avoid linking to the D runtime. It is still possible to use certain template types okay. That's like a nothing. Templates. With templates made easy with C++20. I wonder if you could extern it as C++ to get the template, which is valid. That is extern C++. Then we will take C++. So extern C++ is kind of like better C and how much support it has. It's a question mark. I found out there is a Rust problem where they are trying to rewrite the Linux kernel in Rust. Yeah, like Rust utils. Let's make Linux bad again. It got good in 2026, so we could rewrite it in Rust and make it shitty again.
96 and Jester, using C++ 33M. Think C++ is not overly complicated. Just runs a protected abstract virtual-based pure virtual private destructor, and when was the last time you needed one?
It expects a C++ compatible thing. And why am I compiling it with better C if we're trying to extern it as C? That doesn't work. There's no C++, better C++. You know, extern C++ is a no-brainer, and that's a fucking dumb idea. Why would I do that? Also, if you missed it, we disassembled this too. But error, unidentified identifier, undefined identifier. Yeah, but that's a template, so the template's going to be defined later. It's a T. I wonder what AI thinks of this. I didn't want to have to do it, but today I am become Grockenheimer, user of AI. Because I don't think there really is. Oh. But I don't think anybody's going to cover this. It says explicitly that you can do macro, or like the fucking one thing programming, but like you need to define .vec2 as a function template. Wait, did I forget to do that? Am I brain damaged? Oh shit. I am become brain damaged. Destroyer of code. Fuck. Thank you AI for saving my program today. That looks like it's right. Then we pass everything correctly. It will just work. NVIDIA. Skibbity NVIDIA. On NVIDIA. Let's do this shit. K-fish. I'm getting tired of that voice. Let's change it up. Can you guys hear it too? Where did it go? I want to mess with the TTS, please. Life is too long to know C++ well. Dash. Eric Nagum. Thank you, Eric Nagum, for making this wonderful episode possible. Alright, let's redeclare everything as floats. It doesn't want to work with T. We'll try floats first, and then we'll write it to a T. So that way I can use my better C function. By the way, you know how D is just C with name mangling. It's all it is. I looked at it, I was like, what the hell? What the helly? What the fuck is this? OBJ dump dash D. Ah, look, a full program. F frame. Dot E. The dot F frame. So that's what it should look like. Not this, which I think is just a comment. I don't know what this is, but I see a lot of move SS, so like floating point stuff. CMP, that and that. So first it compares the register RDX and RDI. So compare RDX and RDI. I'm guessing it compares them to see what is going on. Set NE. Bro, I'm gonna have some fun with this. I'm gonna pull out the... I'm gonna search up what set NE is. I guess it says set not equal. Yeah, set if not equal. Okay, so set if not equal. We're gonna disassemble this. So sets if not equal percent %AL. I'm guessing this is a test for if it isn't the right value or something. Like if it isn't the right type. But anyway, .vec2 now exists. You just have to declare it as floats. But the problem is, you see, if you were to compile it to an object file, you can't necessarily link it. So, the real question is my compiler finished? Is it done yet? Can you hurry up and finish my compiler, please? I've been waiting a long time for my compiler. My compiler needs to finish. Oh, good. Linking static library. Alright, we'll be back to the compiler shit soon. Tests. So here it tests RDI against RDI. Then set equal, or set if equal DL. So then X or PS. Wonder what that is. X or PS. Bitwise logical operation. Oh. It's a logical, it's an XOR packed single precision float. Or XOR, yeah, no, XOR packed single precision float. Interesting. I think this is part of the, yeah, this is just part of the x86 stuff where it uses like XMM registers and shit. That's really interesting. That's fucking cool. Okay, so then we have OR. So it ORs them. AL or DL. And then jump if not equal to .vec. Move EDI to EAX and puts in a constant of whatever that is, 0x3 into EAX. No, it ends 0x3 with EAX. Oh. Compare 0x4 and RDI. And then it has another line here where it does, what is that, 25? Or something? Jump and equal or something? Damn, this is really cool to look at though. That's just LLVM doing its stuff when we do the better sheet. But I think what happens is we need a different linker script to get it to work with the T type. We need to get it to work with T. I want it to be see, the reason it doesn't work is because you need to have it as a module. But the problem is to compile it as extern C would just be, well, couldn't I just use all of this? It will still be better C, but the module, we handle it at compile time. We call this kman, all right, or kfish, right? Kfish module. All right, so what we're gonna do, we don't have to compile it to an O. We actually need to do something different. We don't compile to O, but we link it at the same time as we do it. So main.d and then kfish.o or .d. So that
added to C++ are intended to fix previously new features added to C++.
Thank you. Okay. kfish.d, undefined reference to main. Something to do with the thing in here. Because these are now different. Oh, right, I'd have to rewrite this all as a template. T, so they'll all be T now. So to use better C, you need to have it. But the problem is, we can't just do that. We can't just better C this and use it as a template. The reason we won't be able to use a template is due to the interesting quality that this has, where if it's not a module, you can't use it at the compile time of the other program. So what's stopping it from being used as a template is that I think it has to do with the fact that, like, you can't link templates in after the fact because they're already written. It's basically just, you'd have to extern to that code, and, you know, at that point you might as well just use it as a DLL, which would be a little slower, a little more CPU intensive to load it, but it's better because a DLL or .so, you can just call them and then you don't use as much memory. So that's the advantage. Then you save memory on the functions. You can write hella functions. So if we had to write it as better C, then yeah, we would need to use functions. But we should be able to do that same command and it will just work now. Oh, I'm so close. We're so close. Configuring incomplete errors occurred. Fuck. What is it? What does it configure? Oh, it was the final checks. What did it throw? Use LLVM. Unwinded is set to on. Okay. So, we need to redo the this, but we need to have that. If that makes sense. So it was running the tests at the end of the make. We need to just add this in there, and then there we go. That should fix it. Oh. CD ... There we go. Hopefully it doesn't throw any exceptions here. We have to redo the whole compilation again. That's fine. I don't mind. I'm in the D grind set anyway. Build files have been written. That's a success. And then we just have to run make dash J and proc. Ah, cd into dot build. Hopefully it just works this time. Oh, it's going through the whole entire steps and gets the end. We might need to remove build before we can do that. Configuring done. AMD GCN and AMD HSA. LLVM. Built target generate C++ headers. CMake error at LLVM cheat projects execute process. Just do it again. It will figure itself out. Remove build. Then rerun this. Alright, we should be good to cd into build and then rerun the compile command. Hopefully it doesn't break. Yeah. Good solid stuff. I love C compilation. It's my favorite. What do you guys think about C code? Compiling C. Isn't it good? Is it plus plus? I like compiling C. Xorps. Flat assembler. What's the most obscure assembler of all time that I should totally check out for a video? And you know, a lot of what we're working with right now is like the most experimental shit I've ever done. Lately, we've just been doing so much experimental shit, like writing dealing programs. Experimental. There we go. There's my little jet engine taking off. Taking to the skies. The little jet engine. Rustites. Maybe we can compile that, but like not better see it. So we will just compile it to C. And then boom. And then actually, technically, you can do dash FPIC.
36 in Chester, 0 C++ 33 in. I consider C++ the most significant technical hazard to the survival of your project, and do so without apologies.
Alistair Cockburn. What a funny name, bro. Let's try to make a DLL and just use extern C. I thought fpic was to make a portable something something. Bro, that shit's speeding up right now. I ain't gonna lie, that's must be processing a lot in there. Remember, guys, C++ is a horrible language and should be forgotten. It's best left in the dumpster. Create a static library. Oh, you could do C99 as well. I want to try out that. That looks fucking amazing to try out. Let's try dash C99 on it. Do not write object file. Write object files to directory. Oh, right, so if you wanted to clean them up, that'd be actually really cool to do. Object directory. There's so much stuff you can learn, but relocatable references, non-relocatable code. Dash shared. So that's a create a shared library DLL. Okay. You also create a static one. And I think we'll learn makefiles in a future episode, since I really like C. Dash shared ls. Look at that. libkfish. I just made my first libkfish. libkfish.so. It's a dynamically linked library. Let's go ahead and see if I can make it better C. Did that work? That took way too. That did not work. nm libkfish.so. Let's do dash h. Dash O. Oh, wow. Wowie. That is, that's an SO file. Shared object file. Let's see. OBJ is my favorite. Dash T. I see T's in here. Dash, dash capital D. Disassembly of section got.plt. Got. Bad. There's a bunch of bad ones. It doesn't know what they are. It has no clue what those are. Dynamic. Bad. Alright, so I now have a shared library. Now, if I compile this with float, technically, why would you do it like that though? That's bad. That's evil. You don't do that. No. Extern C though. Damn, that's pretty cool though. What I really like is that it compiles down, and I mean, I guess we could try out like Odin and other stuff like this. Like, I actually really understand how to use these things now for writing like things I would actually use, like a library that you can just plop it in anywhere. Be like, all right, I have what I need when I need it. A floating dot, but like here's Here's why templates are important and not there's a lot of add in there, by the way. I noticed that it's just all add. We can't write a function and use float because it's dumb. Because if I just use float arrays, I'm locked into the float array ecosystem. I don't want to be a float enjoyer. Floats. But what if it's a double? Like, what if? Let's see if that will compile correctly. So that's a shared object library that should be better C compatible. So now, let's do the obj dump on it again. And it has an init. I didn't have that before. I don't remember that having an init. I see ds add. I see bad a couple times in there. That's fine. Dynamic. GNU .vec is included. See, .vec now works. That's what .vec looks like. It's a bunch of floating stuff. So yeah, these take up a little bit more space than if I were to compile it down to like an object file and then you statically link it in using a compilation steps. Pretty interesting. Wowie. Wow, that's an off. How was the compilation going? LLVM instantiate. LLVM instantiate. Educate. Edumacate. Yeah. Alright, so if I do LDC2 and then main.d and then dash L kfish dot, we're gonna run into a problem. So the problem is gonna be, I'm pretty sure that's how you specify libkfish.so. However, the capital L specifies let's actually do LDC2 help again. So linker LLD, set the linker to use. Oh, linker flag dash L. So that just means it passes a flag to the linker. If your linker's LD, if your linker's LLD, BFD, gold, whatever, and you've set that, so these are all linker stuff. Hi. So if we wanted to link with gold or like BFD or something else, that's an option. If you know those ones better. Now, by default, I believe it uses LLD. Technically, you could use LD, but we'll try it with this one. So, would you please tell me where I should start learning about Linux? I don't know. For free? Yeah, I mean, my channel is a good place to go. I don't think I paywall any of my, like, Linux videos. just the gaming ones. I mean, but that's only temporary, too. They'll come out eventually. But, I don't know, I've done hella videos on Linux. But lately I've been diving more into, like, compiler stuff, so, like, for, like, my compilers and things. But if you want to learn Linux, the best place, besides my channel, would be other people's channels, like Brody. I don't remember his last name, or whatever. But yeah, go check out his channel. It's pretty interesting. Actually, okay, I can just pull it up here. I don't remember his actual name. Ah, Brody Robertson. This guy. He does stuff on Linux, so if you want to learn more about Linux, I think I'd go there first. Mostly the stuff I'm doing is like super advanced stuff right now, but back when I was first getting started, it wasn't. For example, we're compiling a LLVM backend to target GPUs for compiling code from a language that doesn't support GPUs. We've covered things like installing Arch on devices that you don't want to that don't want to install Arch. They don't accept Arch. For example, the Odroid M1S doesn't like Arch, but we made that happen yesterday or the day before yesterday or whenever we did that. We also tried Gentoo on Arch, or on the Odroid M1S. We tried this out. We almost got there. We trued it into it, and then I screwed something up. And then we've done a lot of stuff. And then I think next up we'll be doing like server stuff this weekend, like actual real servers. I don't use Arch, by the way. Oh yeah, that's fair. And I'm so scared to run this, but like the easiest way to learn is to run it and fail. Oh. So you're using the distro Arch? Yeah. I like to install a lot of the stuff from scratch. Actually, lately I've been getting into compiling it. I might turn into one of those Gentoo weirdos. Gentoo, by the way. Once I use Gentoo, bro, all the Arch users better watch out, because I'll be using Gentoo, and I'll be cooking. Oh yeah, we set up distcc yesterday. That's step 1 of Gentoo. Genetui. It's like Ratatouille, but with Gentoo. It's still throwing undefined reference to main.vec thing. I'm guessing, what if it doesn't need all of this? Oh, I could have done it better. Comment it out. Comment that out. So it doesn't need that. For now. Okay, it won't link. Alright, do your stuff. Oh yeah, we set up a Cinnamon desktop too. That's like actually what I think I'll do for now on the Cinnamon is pretty nice. I like that. This is FVWM3, so I have this window, or this desktop, which is the infamous C++ desktop. Then we have the NVIDIA desktop for NVIDIA, to celebrate NVIDIA Gate. Arch desktop with Todd Howard, making sure that you're writing Skyrim good. We have ArchChan, a classic. And we also have the legendary Creaton of Linus. What a holy relic. And then we have Architure Labs. I love Architure Labs. What an amazing place. I mean, you can do hella custom stuff on Arch. Main.o and function dmain. Oh, you know what it is? Because I didn't define it correctly. That's it. me switching things up every 5 seconds. Of course you're not gonna have compile time from a .so file. Let's see. We're rewriting the... Oh! .2vec? Maybe I should just write C code. Maybe I should quit delaying. Better see the killer of souls. Pac-Man SYU. This is the saddest of all time. But maybe it's just not finding it? ls. Is there a main.o? There is a main.o. So why isn't libkfish.so linking? Or am I doing it wrong? What if I'm doing it wrong? Let's go and dig in my deep old examples. I wrote examples for a reason. That is so we can re-reference them. These are from ye olden times when I was still a noob at programming and not an 8-month expert at it. Programming from scratch. Wowie. Actually, you could compile Fortran to this as well. Probably using AMD Flang, which is also basically just like Clang, but, you know, Fortran. AMD Clang. Actually, Fortran's hella awesome. If you were to get into programming, I'd recommend Fortran as like a first pick. It is still kind of confusing and it's got limited docs though. But sup, hacker main? What's up? We've been failing so hard today that I've been yelled at 300 times by Jester0 C++ /M. I invented the term object-oriented, and I can tell you I did not have C++ in mind. Then we also did some ASM dumps, but not soon. We're gonna do another one soon on this one, just to see if it actually did anything. I wonder if I could just force it to compile it. Actually, LD. Oh, I'm still in that one. Oops. I'm in /root. Fuck. Heisenberg. I should have example programs. Yeah, programming examples. Well, you can start failing, but you'll end up succeeding. Yeah. Yep, that's the hope. First GTK. What if we set up VLang again and try to learn some VLang? But I don't like VLang anymore. I feel like I'm retired from VLang. Unless it has an LLVM backend and it all compiles into LLVM bytecode and IR. I don't know what I'd be doing any other. We haven't tried compiling it to LLVM IR yet. That's an interesting thing because then you can look at what LLVM assembly looks like and stuff. But I'm pretty sure that's what we saw. I really like the UI of the file explorer and other stuff. Thank you. Yeah, I just used Thunar on this one. But also this is just a theming thing too. Then this was X resources. Fish AI v0. Oh wow, the ancient programs in here. Do I have there's gotta be a .so example in here. Oh, I think Odin has that. I think I did that in Odin. This one. Oh, that's an OS. Then I have, what's in this? Hello world.odin. Seashell.odin. That's Arch, by the way? Yeah. Kernel D example. Linker.lv. There's an LT. C# examples. We have oh no. Comparison.d. Hello world.o and hello world.d. This one we called from C#, but that was interesting. I don't have any .so examples. Or did I miss them? D examples. Vibed. Ref. Maximum overdrive. What are these named? This was before I knew templates. Which is a recent development. Actually, there's another thing I need to learn too, which is the they're called thing. I don't remember what they're called. But anyway, so if we extern C there, oh, wait, what? Oh, I wonder. This is a good question, too. I didn't try this one. Maybe we need to declare these somewhere else. Potentially need an extern block for those. But that also puts it globally, so technically I could extern that. It's like basically importing it. It's basically like importing it, I think. Try that. Yes, me too. I will also declare the darkness a global variable. But this won't really change anything, but this just makes it a local one. However, if we rewrite this program in Fortran and extern to Fortran's like the only other language that I've actually really fucked around with too much. You use the ISO C binding because they're science nerds and they like naming shit ISO. How's this going? 81% on my compilation for my LLVM backend, which is the side plot of today's episode. By the way, side plot. Like how I stayed up all night trying to set up or compile GCC. I'll be redoing that tonight as well. We are. Oh, better see the killer of souls. I wonder if it needs a C ABI, like you call it from another C program. This should work though. I mean, reasonably. Unless it needs a reference. I mean, I guess you could take a reference. User bin main ld main.o in function function d main. Undefined reference to .vec. Wait, isn't there a way to set the... ooh, here's a good one. Let's try ldc2 -h. -h. Linker's at the bottom, so we can set CC flag. Pass CC flag to GCC/CLang for linker preprocessing. This is the stuff you need to learn though, is like all of this is gonna be useful at some point if you're gonna do any compiling for like making your own OS out of a language. You need to know the compiler, which I didn't really know when I was doing that. I just followed a guide. So, but this stuff is super important. Learning LD is like the fundamental of doing crazy shit with programming. But also, there's also other things too, like preprocessor. D-Lang doesn't have that, but I believe C and maybe C++ do. I don't know about C++. GCC, C-Lang, the C compiler for linking and external assembly, defaults to the C compiler environmental variable. Let's see. There is none. There is no C compiler dash GCC. So technically, brainwave. Oh, do we have AMD cling? Oh. Ho, 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 ho. Yes, we do. Brilliant. Okay. And this is where fun stuff goes into play. So we're gonna set up an... What if we set the CC to AMD clang for the first compile? So ls, let's rm-rf libkfish. We might make it lib, but and then let's see. Technically you do rf or just do f and then it will remove, because you only need R if you need recursive for a directory or something like that. If you wanted to do like, you could do like lib or directory /* to do a whole directory or like a bunch of files in there. You could also do that for like copy. You can do asterisk is super useful. Me, I practically live in the terminal. I don't really use much else. I do have Thunar installed, but I don't really use it much. So what I was really more concerned with was the linker and using LLD. So you could pass -- linker equals LLD in this one. So where's the one where you compile to a .so? Which should be fine. That externs see everything, so we're gonna use the linker equals LLD and the GCC or is gonna equal AMD C-Lang. Alright, let's see if that changed anything. Nice keyboard. Yeah, you can hear it. It's very nice, right? I like the sound it makes. Let's do LS real quick. Let's see, libkfish. It compiled. I'm not sure exactly what it did. If it externed C. I wonder if it doesn't extern C, or if it doesn't compile this correctly because it's got extern C at the top. I wonder if that's the problem. But we saw that probably wasn't. We could do obj dump. Now that we've also added 2 new factors into the equation, my brain is gonna explode because it's gonna not work. Obj dump and then do obj dump dash what was it, T or dash D for disassemble. We're not gonna disassemble it. We're gonna do, I think T is for symbols, and then libkfish. And now we have kfish.d .hidden. Lots of .hiddens. .vec. Alright, so .vec exists. And it is callable. Lots of do in it, do in it, do finny. So that's a SO file. Now, to link it, we should try, let's see, libkfish -03 for optimization 3. And then let's try... Technically, if you do -0, it defaults to the optimization of 3 as we saw anyway. Linker equals LLD. And my other one will be... Now you can also pass L flags, which here's one of the things which is amazing and why I really like LLVM. Way too much. Way more than anybody should. Not the language reference. That doesn't really matter too much. That's just for like if you wanted to develop it. LLVM lexicon, that's a bunch of like vocabulary terms. Who really cares? But if you really want to learn a lot about LLVM, the tool section is awesome. I like tools. Like you got a hammer and a screwdriver and a pair of pliers, but like instead it's a fucking compiler. There's lots of information here, but undefined behavior. Awesome. Machine IR reference manual. X-ray instrumentation. On how to use X-ray and LLVM. I just want to read the tool section real quick. Getting started tutorials. You can also make your own compiler built off of their backend. So you can build the front end for the compiler and then just use an LLVM backend. And it really makes it simple. That's something else that I think we'll probably cover. User guides. How to build on ARM. How to build with profile guided optimizations. How to cross compile. How to build C and front ends and stuff. But LLD. So there should be a section on LLD. Or maybe it's in this section? Maybe it is in this section and I just am dumb. Getting started / tutorials. Programmers debugging performance. Here we go, the LLVM build system. You got LLVM, which is just like a library, I guess. Clang and LLD. Well, it's more than that. It's like a tool. Here's compatible platforms, PowerPC, Long Arch. I've read this, like, the entire page before. Might read it again someday, I don't know. I'm a real diehard LLVM enjoyer. AKA I'm a cringe lord. And I enjoy LLVM. Oh my god. Make install. That's just how make works. That's just make. CMake and make. Which LLVM kind of taught me how to do that. Hey, how's the compilation going now I think about it? Alright, we've almost got our backend compiled. Spark v9. Good, it's throwing lots of errors. That's a good sign, by the way. I am enjoying those errors. Good. Building CXX objects. Clang LLC. Alright, then it gets to the testing portion, or where it starts to do the C++ exclusives. I love my C++ exclusives to be very exclusive. But yeah, you got lots of tools in there, like LLVM disassembler, and like take stuff apart and put it back together. LLVM, best thing ever for development. C++. C++ rots the brain. C++ is to lung. Or, no, C++ is to C as lung cancer is to lung. That's not my original. That's me stealing somebody else's quote. Oh, it's not my fault, because Jester told me it. So the last step is like linking. The first step was like pre-processing it. And in between that, you have compilation, assembly, and probably something else. I don't remember what it was. And at the end, performs tests. That's pretty typical. Now, hopefully, it passes all the tests, and I don't have to go how is this broken and how do I fix it? Because I don't have that much time today. I have until like, I have like 30 minutes left, I think, for the, probably 40. Adding RT, shadow call stack, configuring done. That's a good sign. Hopefully it's not doing the C++. Oh yeah, runtimes. There we go, we're at this step. This is where it failed last time. Copying the headers, and then it returns that. CMake file lock CMake. Build target CXX headers. Error. I think it was going too fast. Makefile all. CMake error at LLVM. Oh. I actually don't know what this means. Like, you'd think for knowing so much about LLVM, but I don't know a shit about CMake. CMake all. I only really started using CMake when I compiled Doom that one time. Let's see. The answers are in the forums or in the machines. Error is fatal. Alright. File lock CMake failed with exit code 2. Machines. Machine God, tell me what the answer is. util-linux, which provides flock, file lock on Windows. So I'm missing a file. Install util-linux. That a required external tool such as lock or lockfile. Oh, okay. That's interesting. Let's see what that could possibly be. That was like a nothing burger too. Actually, that's wrong. How did that go wrong? So let's see, file lock. Makefile 136 error. CMake error at. Did it just take the top part of it where it says exit code 2 and say, that typically means? Oh, no, it didn't. CMake error at that. Check path. Verify the tool generating the error is accessible by running which tool, where tool. But there is no tool. Disable file locking. Oh, maybe it just needs file or flock. Flock. Yeah, sudo flock install flock camera. Which flock? Okay. It is installed. That's like that's a basic installed thing. That makes sense. As it handles concurrency and file locking. So I should try Ninja. Actually, you know what that means? We'll just do -J. No, we'll just do make. With one core. It'll take longer, but trust me. We just need to get past that file lock portion. Because once it gets... We've already gotten it mostly compiled. So we don't have to do most of that shit. We just have to do this part where it puts all the headers in. I'm pretty sure. And then after that... So this part's going to take a while now. That's fine. Performing build step. And then return code. CMake at... But then failed because... Oh, okay. Fatal error. GNU stubs -32 not found. Error unsupported architecture. Lib unwind config.h. Oh wowie. There we go. That's the culprit. Let's see. Lib unwind fucking C++. I love it. Copy selection to clipboard. So we have that now. That's beautiful. It is missing a dependency for AMD. Yeah. What is the dependency? Shovdicate. Mr. God, figure it out, please. The errors indicate two distinct but unrelated problems, causing unsupported architecture and missing 32-bit library. GNU stubs dash Arch Linux lib32-gc. Failing to correctly identify your host architecture or is incorrectly forcing a 32-bit. That's hopefully not right. Wait, so maybe we should just install Ninja. It says Ninja, bro. Why though? Why do we need Ninja? librt compiler RT default target only is set on to prevent the build system from attempting to. Oh. But we're trying to build an LLVM backend for a GPU, right? So the target wouldn't be us. So lib unwind. What is lib unwind config? .h. What even is lib unwind? So that's like the real question, the deepest question of all time. Lib unwind, which is it's for debuggers. Ah. What if we just removed that from the thing? And then we also we'd have to do skipping this part. What if we do just make -I and ignore that shit? I think I might be onto it. Make -I, ignore errors, right? There's no problems there. It's just a slight little error. Then we can still get it to work. I think that's what we did yesterday with this CC, compiling it on the Debian ones. We just did make -I and it just fucking went all the way through and it actually still works. Include GNU stubs -32. It can't include GNU stubs -32.h. Oh, but those are from those? C++. We're just not gonna build 32-bit programs then. Looks like it's made a successful backend for us. Oh, that means it won't be able to do, it'll be fine. Surely it'll be fine. Anyway, let's see. That's really going slow though, too. Maybe I should have done the -j nproc again. But it's building libc math and everything. See, the reason that I think it'll be fine because it's just going to be targeting a GPU anyway. Why would it matter if it's got a 30... Well, I can think of a reason it would matter. And it's that like the underlying program relies on some of those old 32-bit features or relies on 32-bit features, not like the actual, since this is the backend of the compiler itself, I can imagine it might use some kind of bit manipulation, especially since it's a compiler, and bit manipulation is kind of useful. Key example would be, for example, Quake 3. Alright, so we now have a no install step completed, built target, and then it ignored everything. Brilliante. Let's go ahead and CD. So we're gonna move this. What is this? What directory are we in? Build target. All right, we're gonna CD into home. We're gonna MV the build. So it will be LLVM / build, but just the entire thing to here. And then we'll CD it into CD in. I was typing what I was thinking. ls. I think we run the command from here. Here we go. Home, and then home, it'll be in home/build now. Yeah, home/build. Everything else looks good. So run cmake. Failed to execute LLVM config. Unix files, type release, install prefix, home, and then home/build. Actually remove that. We don't want that. Let's actually, maybe if we ran make, maybe it's still initialized and we could just hit make -n or -j and then nproc. Ah, I got it backwards. Let's see. Alright, actually, cd ... rm-rf build to remove any cache stuff. mkdir build. cd into build. Right, and then run the cmake command. Alright, and configuring errors occurred. Intrinsics.td not found. This has to do with cmake warning. Heisenberg build this lib clang 24. It needs a clang specification. Needs me to specify the clang path. Actually, dash DLLVM enable projects clang and LLVM. Dash DLLVM enable what was that again? DLLVM enable projects. What if it needs that? I think it just needs to be pointed towards the actual directory, but clang, comma, LLD. Intrinsics.td not found, and it needs the compiler runtime, which we found was the problem last time. Or we set the LLVM runtime libs to equal off. So we could do that one. Could try that out. Although this is a very nice idea. I think because it's a string, it needs to go in these. Ah, it needs to be dash D. Oh, wait. What? Off. File. Oh, okay. On. Not found. File intrinsics.td. cmake txt. Let's figure this one out. I did not find any of them in lib slash in my home clang 24 slash lib slash unknown slash clang slash 24 lib unknown. Let's see what we can do with this. I think we'll get to like an LDC with a fucking backend by like the end of the week probably. If we just like split up every episode, we just work at it a little bit more and like we do it on the side. I don't really have anything planned. I don't got like anything I'm working on really until this weekend, and then we'll hopefully be working on the server. Oh, that also means I'll be cleaning out and preparing refurbishments for the server, so then we can do that and get that ready for this weekend. Fix compiler RT unknown directory and missing libraries. Cannot determine the OS/architecture suffix, which is GPU. Install LLVM runtime libs equals off. Explicitly define the paths. Alright. Compiler-RT build. I don't even know if you need that though, because like technically if you can specify it as an AMD C-Lang compiler, then you could technically compile it with better C to be a D-Lang GPU kernel without even doing anything. You don't even need I don't think you need one. But you see, AMD C-Lang is really good because it, like, if you have like an AMD CPU, you can technically use that to get your local architecture, pretty much. Like what I'm doing here, I'm able to do --GCC equals AMD or AMD things or AMD C-Lang or C-Lang. Undefined symbol dot underscore vec referenced by d main. Anyway, I'm sorry, I got so distracted I lost where I was at. So it wants me to do dldc install llvm runtime libs off. It wants me to end the world. Okay, equals off. Step 1. Then it wants me to explicitly state compile cmake runtimes. I don't think this will work because they're not compatible. This is the most amazing idea of all time. Oh, we don't even have a C-Lang in there. Like there is no C-Lang. Just AMD GCN. Oh, that's interesting. That's what all the makefile and stuff did. What an interesting thing. The makefiles. The directory structure you see confirms that AMD GPU runtimes, specifically compiler RT built-ins, has successfully been built. Built-ins AMD GCN-AMD HSN bins. Next steps for installation. To make it usable by Clang or for compiling, you must install them. This copies the bins into a standard layout under your cmake install prefix. No, we're using them to compile D-Lang. Using it to compile LDC2. Let's see if it has any advice for this. But I don't think it's going to pull up any results. The only thing that's close is decompute. And I have no idea how that guy did that. But I'm trying to do what he did. Make my own version. First, for AMD GPU based on your version. Okay. Configure LDC2 to find. You have two primary options to make LDC2 pass paths via command line temporary. Wow. So you could do. Oh, this is interesting for linking. When compiling LDC2, you must explicitly tell LDC where to find these libraries, as it does not automatically detect non-standard or GPU-specified runtime paths. Ah, interesting. You see, here's what we need for D-Lang. We need We need D GPU. That's like a subset of D targeting GPU. That'd be awesome. And I think we're gonna make that happen. Update ldc2.conf permanent. To include your custom runtime libdrs list. Okay, usually located in /etc/ Okay, that's an option. With support, if you're currently building LDC2 from source and want it to bundle these libraries to avoid external dependencies, disable automatic copying if failing. If LDC build fails because it can't find the standard Linux library, disable the automatic copy step. Manually specify the paths. Decompiler rt libdir config. So that's what we want. We want this one. Critical note, while you have built the C runtime compiler RT AMD GPU LDC, the decompiler relies on the D runtime and Phobos, not the D standard library. D runtime Phobos, simply having libclang underscore RT dot built-ins dot a is usually insufficient to compile full D programs for AMD GPU. You might also need a version of D runtime compiled for the AMD GCN or AMD GCN and AMD HSA target. Damn. Wait, but that's like for when you get to like actually when you're writing it. That's really interesting stuff. This is honestly the most insightful thing of all time that I've ever read from an AI. But it's also, of course, missing a few key details. Current state. LDC does not ship with pre-built D runtime / Phobos for AMD GPU. You would typically need to cross-compile the D runtime libraries yourself using your new C-Lang toolchain before LDC can fully target AMD GPU for anything beyond simple freestanding code. But like, this is why LDC is cool and why LLVM is cool, is because it might potentially be possible for this. The problem is, I think I'm done with all of that shit. That's way over my head too. It's missing a few key details. It's way over my head. Because we're not gonna be able to build that. There's no way. Now, technically, you could probably, like I said earlier, compile using the AMD C-Lang compiler with better C. Problem is, again, like they specified, it is the Phobos library. Phobos. So the reality of it is it all comes down to libphobos. Do I want to try what it says to try, which is to use decompiler rtlibconfig to force a full path, though this variable often expects a generic OS name, not a full triple making configuration or LDC2conf editing more reliable than for GPU targets. That's what they mean by full triple in here too. So triple, that is x86, OpenMP, then you would do LLVM runtimes, so your AMD GCN, or you could do your NVPTX. So the full triple would be this, I don't know. Oh wait, maybe it's LLVM runtimes, x86 PC, and then your OpenMP, or your offload, or maybe both. I don't know what a full triple is. That's like a weird way of explaining it. LLVM runs. The reason that this all would work is that you'd just have a... It's okay though, I can write C-Lang. You guys ready to see me watch me write some C-Lang? See, I'll forget about all of this X turn C, but we'll try writing C lane. So new. Let's try it out. What do you need to include for this too? You should try Zig. Does Zig have GPU compat? Or does Zig have LLVM as well? This is a good question. You know what's great though is VLang. I think I know more VLang, and I think it's been a month since I touched VLang. Well, does Odin have targets for AMD GPU? Open MPI. Next episode. Confirmed. No, I'm joking. We'll just be continuing to learn more about the LLVM compiler, but we learned a lot today about actually going through the steps to compile it and attempt to compile it for GPU targets, although that didn't go quite too well. Not sure why. We need AMD D-Lang compiler. LDC with a... Let's see. LDC with GPU backends. I wonder if that's a thing that somebody's already done. There's also the option to write my own compiler that targets the assembly, because I think you can actually disassemble like a GPU kernel or something like that using obj dump. ARM backend. That's interesting. This is actually a good starting point, actually. LDC with that. Here we go. This is a good starting point. Hello, I would like to cross-compile D from x86 machine to ARM target of ARM GCC toolchain. LDC on Linux on ARM is fairly complete. I think it is fully supported platform. Great, I didn't see it. However, I have ARM none Linux GNU ABI. What about Musil too? Like a Musil backend? Like Musil libc? Zig has LLVM support as far as I know. That'd be like an interesting video. I feel like there's a lot with GPU stuff that is unlocked because LLVM exists, and like that's one of the, I think that's the main point of this video. Oh, is that not the password for this one? That one was.
Language designers had two competing ideas as to how they should solve some problem. They said, okay, we'll do them both. So the language is too baroque for my taste.
I bet there's more on LDC docs though. I bet LDC docs has a lot of their information. OpenSUSE. I know what I'm going to be reading today, though, if I have free time. I'll just be reading hella LDC stuff. LLVM decompiler. LDC to LDC2. Lots of stuff on ARM, though. Because that's, like, the primary reason that LDC came about, I think, is because of, that. Is because of ARM, specifically. LLVM probably also came about because of that. So you need some way of targeting, those obscure architectures. Target SPERV. I think one of my biggest areas that I need to work on though with this idea I have is to the M triple. Wait, what? Relies on, yeah, the backend, which was promoted to an official target in LLVM 20. Spurv 64, the M triple dash unknown dash unknown. So that's better C. Often required because the full D runtime is not available in Spurv kernels. Yeah, like that's what they said about libphobos as well. Wait, so I can just do this without compiling it myself? My brain cells are gone. Let me turn on the machine again. Let me boot up the machine. Let me get it spinning. Then I'll take a piss. I'll be back. But yeah, no, like if the D runtime is phobos, right? Phobos D runtime. Makes sense what I was doing with the better C portion. So that makes sense. So is this good? Is this code here? Is this code erroneous? Code erroneous. Half-Life 2 hoot today. I'm in a pretty good mood to produce some code. Not of the shared variety, though. libkfish.so. But you also need to specify an M triple. So it said equals spurv 64 dash AMD GCN oh, dcompute integration plus spurv is dcompute, a library for heterogeneous computing. Heterogeneous, what does that mean? Oh, like different systems? It refers to, using different compute units or processors. Wowie, thank you. My day has been summarized in 5 simple steps using AI. What are we doing? Spurv 32. Sure, we don't want Spurv 64? Spurv 64. Alright, and then what is the dash unknown? And we need to dash better C. And we can't do dash C anymore. So M triple unknown dash unknown. But we want AMD GCN. Let's look at, because we're on this website anyway. M triple. Spurv though. Spurv. AMD GPU memory model. Store. Cluster workgroup wavefront single thread. Lots to read, but I will read that later. User guide for a spur target. The spur-v backend can be invoked by the LLC. What if I wanted to do an AMD GCN target, though? AMD HSA, right? Because we know it's AMD GCN 1030. Because it doesn't have a 1035, I don't think. Well, actually, there was something else that didn't have the 1035. It was a Fortran that didn't support 1035 or whatever. And it had, AMD F-Link didn't support it. To AMD object code in .o or whatever. Oh, that's an M triple. So it's an AMD GCN, AMD HSA. That's the triple. Then you do dash better C, and then whatever your architecture on that target is, which is dash M CPU. You don't need SPURV unless you're doing OpenCL, I guess. So that's that, and then you do the target architecture, which is GCN, and we'll have to fetch that. It should be up and running, right?
Does it take to change a light bulb? Now, just declare the darkness as a global variable.
Okay. Just search that shit up then. That has a 1035 or 1030 GCN. Bing, bing. Bing. Hello devices. Wowie. Wowie zowie. Jetson Nano. Nano Banano Pro Ultra. Let's see. GCN. RDNA 2. So how do you target RDNA 2? But that's not the correct GCN anyway. There's a specific subset that it needs. GFX. Oh, that's what I needed. GFX. Which is either 1035 or the other thing. GFX. What's the GFX value, please? AMD GPU. AMD GPU gives you the answer, but I'm not going to. Actually, all you need to do to fix that issue on the thing is to export the correct value to be extern. All I need to do is just export term equals x term then I can do NV top. Sorry, I got that in my head now. XT easiest way to get it. AMD GPU top. Are you sure? I guess it's not a thing. Hold on. NV top? We try MD Radeon top maybe? Maybe it's underscore top. Ah, here we go. GFX 10 underscore 3 or GFX for the specific version that. Now, I think I was forcing it to use GFX, specifically the version 10.3, so we'll just use GFX 1030. But we can probably target the 1034. Let's actually just target the 1034. $10.34. What did I have to put again? It was a dash M CPU equals the number of our target. Aborted. Here we go. Yeah, you need to do dash better C before you call that. Dash better C. Is the compiler set to AMD C-Lang again? Compiler or dash let's do dash cc. I think it's capital CC equals AMD C-Lang. Oh, it is dash cc. What? Oh, it's dash GCC. Broken module found. Compilation aborted. I think you need to call it with extern C first. Call parameter type does not match function signature. Let's see what this means. I figure I know what this means. It means that we can't really run it like this. I mean, I would expect to be able to fucking compile D-Lang into a GPU kernel using better C, but it says it's possible, and I think if we made it with my backend, I think it would be possible. With the backend idea, that's where it's at. Now, I know a source of information we should use tomorrow for the next attempt. Generic float address space 0 generic float. The compiler is generating a string literal in global 1, but the __ assert function call site expects it in constant 4 or vice versa. causing the compiler to abort. This is a known issue when compiling D code with assertions enabled for AMD GPU. Default runtime assertion handler expects standard CPU memory layouts. Should not use host side assertions. Disable them to remove -- release is all I need to add to it. -- release, I guess. I'm not using any strings though. We're not passing strings to the GPU. Surely. Oh. Don't link it first. We're just gonna make a -c file. And then let's do obj dump -t for symbols in or actually let's do the full disassembly for kfish.o file format ef. Can't disassemble architecture unknown. What have I discovered? You can't disassemble them. What? So that means that this code, as soon as it is compiled, is unreversible. You can't look deeper than that. Oh wow. That's the most interesting thing of all time right there. Like I was thinking I might be able to finally uncover what GPU assembly looks like. But this is what GPU assembly looks like. File format ELF64 little. OBJDub can't disassemble it. Unknown. That's what it looks like. That's it. Well, let's see if we can get names out of it at least. T. It has .vec. This one symbol, .vec. you can't get any better than that. -o. But AMD 64. It's a little Indian though. Intel. So, can you disassemble? You'd have to use a hex editor, and even then, we don't know the instruction set architecture for GPUs. Even AMD GPUs do not have that public. That's a proprietary thing. AMD GPU ISA. Like, you cannot find this anywhere. Wait. We need RDNA2. Supported architectures. ISA documentation. XML schema is a new specification. Get the XML files. ISA decoder API and more. We've made an available set of C++ tools for parsing and using AMD's machine-readable GPU ISA specifications. Well, I think I know what we're going to be doing tomorrow. Looking at GPU Open. Revealing the secrets of GPUs tomorrow. I'd like to thank you all for watching. I'll see you guys